Cramer's rule. Well, consider a system AX is B where A is an n by n invertible matrix. Then we know that there is a unique solution to this system. But we can also find an explicit formula for the vector x solving this equation. Since the components of x are given by the quotient of two determinants. So xi, the ith component of x, is a determinant of a matrix A where we interchange ith column with B. We divide it by the determinant of A, which is non-zero since A is invertible. Yeah, so we take a matrix and A has columns Vj, and we change the ith column by B. We calculate its determinant and we divide by the determinant of A. This is Cramer's rule. So for example, consider the following 2 by 2 system where we have a coefficient matrix A equaling -2, 4, 3, 1. And the vector B is given by -1, 1. Yeah, first check that the determinant of A is -14, so that A is invertible. Then calculate the determinant of A where the first column of A is interchanged with B. So it's a determinant of, we put B in the first column, -1, 1, 4, 1. So determinant is -5. And the determinant of the matrix A where we interchange the second column with B is the determinant of -2, 3 and -1, 1, which equals 1. So now Cramer's rule says that actually if we look for x and y, x is -5 divided by the determinant of A is -5 over 14. And y is 1 over -14. This is -1 over 14. So now we discuss a little bit larger example of a 3 by 3 matrix A, of which we know the determinant is 8. Then we calculate 3 different determinants. So we interchange the first column over here, the second column over here with B, and the third column over here. And we're now going to calculate the determinants of this first one. We know that adding rows to other rows, or multiples of rows to other rows, does not change, has no impact on the determinant of the matrix. So we now take row 3 and add 2 times row 2. Well, why are we doing this? Well, we create 2 zeros. And since we now have 2 zeros, it's nice and easy to develop with respect to make a Laplace expansion with respect to the third row. So we get -5 times the determinant of 0, 2, -2, -1. So the determinant equals -20. So the second one. Again we add 2 times row 2 to row 3. Then again, the last row contains 2 zeros, so we may develop with respect to the last row. So this means that we get plus 3 times the determinant of 0, 2, minus 2, minus 1, which equals 12. And finally, again we add 2 times row 2 to the last row, and we get the determinant of 31024 minus 2. 31024 minus 2 and 350. Well, notice that now we have in the last column 2 zeros. So actually we may develop with respect to the last column. So we get 2 times, 2 times is minus 2 times minus 1 times the determinant of 3135, which equals 24. So what does Cramer's rule say? Well, look at the system of linear equations ax equal b again, then we know that x equals x1, x2, x3, and x1 is given by minus 20 divided by 8. So the determinant of AB1 divided by the determinant of A. And similarly we find x2 equaling 12 over 8 and x3 24 over 8. So we get finally the vector minus 5 over 2, 3 over 2 and 3.